Chapter 4 is hardware and software. So this kind of takes a sharp turn from Chapter 3, where it started talking about business strategy and big picture concepts. And this is kind of the nitty gritty. This is the left hand side of that chart with the components of IS. We are at hardware and software. So if we follow along from the book, from the Falcon Security case study scenario that the authors have come up with, what is the big takeaway that we're seeing so far? Well, Falcon Security is not a manufacturer. And they were investigating using the 3D printed parts to make drones in-house for Falcon Security. It could be cost savings, flexibility when updating the fleet. There's some non-printable component parts that make it difficult, so it's hard to kind of replicate that process. What you're doing might not be compatible with internal systems. It's costly and frustrating to be on the bleeding edge. If that's not your specialty, if you're not a manufacturer of something, if you dip your toes into it, it's going to be very hard and expensive to try to be at the cutting edge of technology. Chapter 3 discussed some processes and systems Falcon would have to build if they wanted to start making their own drones. What are some of those processes that they would have to build? Well, we'll go through some of that today. Here are the big 4 questions we're going to get out of this chapter. So you as a business owner, you might not need to know how many bits are in a byte or how many bytes are in a petabyte. You might not need to know that. You probably won't need to know that. But you need to be familiar with some concepts like virtualization, the role of like a computer server or virtual machines, and these are things that can affect competitive strategy. New hardware can affect competitive strategies. There might be new possibilities. Of course, you come up with your competitive strategy first and then build IT around that. But how can hardware affect that? What do business professionals need to know about software? Everybody uses software. It's something that you're not going to think about when you're creating your business plan, and you shouldn't. You should come up with your business plan first. But what do you need to know about that? And is open source software a viable alternative? And I'll sprinkle in some of my experience that I've had with that, some of the difficulties and positives with it. So, what do business professionals need to know about the computer hardware? Well, first, we've got a central processing unit, the brain. That's what kind of controls everything. Like the name says, it's the central processing unit. You can have, well, it started out with just one processor, but now we have dual processors and quad processors. So dual meaning 2, quad meaning 4. 4 processors working together to accomplish a mission. You can have different speeds, function costs. It used to be simple, where you could look at a processor and say, this was 333 megahertz, and you knew exactly what that meant. But now, obviously, 333 megahertz is very old and slow, but you could have a 5 gigahertz processor, and you could have 2 5 gigahertz processors, but one of them's performance is going to be significantly different than another one's just because of the architecture. So these things are getting more complex, and the cost is going to vary more. What they're used for is going to vary more. The CPU works in conjunction with main memory, which is RAM. If you ever opened a computer and throw sticks in, those RAM sticks are your main memory. And the CPU reads data and instructions from memory and stores results of computation in memory. So it's working in conjunction with that RAM. So a CPU selects instructions, processes them, performs logistical comparisons, stores the results of operations in memory. That's what a CPU does. Computers with 4 CPUs would be called a quad processor. With 2, it's a dual processor. Now let's talk about storage. What's the point of storage hardware? Well, you want to save data. And you have volatile and non-volatile storage devices. Non-volatile, when you think of non-volatile, think of like permanent. Like you've got, think of think of a notebook versus a post-it note. So your notebook is going to be permanent. You're storing that, you're keeping it. Your post-it note is going to be temporary. You write a note to yourself. You could lose it half the time. It's disposable. You just crunch it up and throw it away. It's not, the permanence of that is not great, but in a notebook it is permanent. Permanent, non-volatile, that would be your notebook. Volatile would be a notepad, it's a post-it note file. So if you turn the computer off randomly, the non-volatile storage, that's going to still have that data on it. But the volatile storage, it's going to be temporary and gone. So we have some basic types of hardware here. Personal computer, that would be like an Apple Mac Pro. Tablet, to include ebook readers, so Kindle Fire, iPad. Smartphone, everyone knows what a smartphone is. Server, it's like a Dell PowerEdge server. And a server farm is many servers. Racks of racks and racks of servers. And what is a server? Well, it supports processing requests from remote computers. So you have a dedicated server that can store data. You have a data server. A server farm would be used to receive and process thousands of requests from a large number of users. You have to have a server farm instead of one server that's going to completely melt down when you have thousands of users asking questions of it. And here's a server farm. Now, when I worked at State Farm, we had a gigantic server farm room. I had a couple of them for the organization, but this is moving away from being on premises at State Farm to being in the Amazon cloud. And the Amazon cloud is just this, but a gigantic server farm, like a server city. I mean, it's crazy how big these are. But companies are moving away from hosting their own server farm to going in the cloud. And the reason why is because that way State Farm or these big companies don't have to hire IT nerds to go in and make sure it's all set up and working correctly. So large server farms by Microsoft, Google, Amazon, they cost $1 billion to build and they employ about 50 people to operate. Let's see here. Binary digits. Now, personally, I don't think that you as business professionals are going to need to know how binary digits or bits facilitate everything that happens with your information systems. But this is a requirement of the course, so we're going to go over. Computers represent data using binary digits called bits. Bits are easy to represent physically. They're just on-off. Everything with computers is on or off. That's why you get ones and zeros. 0 being off, 1 being on. On and off, that's how everything is built. Which is pretty nuts to think about, that someone came up with this system. But everything is represented by zeros and ones. This is supposed to represent a switch of either open or closed. Open meaning off, 1 meaning closed, meaning on. And there's a couple ways that computers can do this. Light switches, magnetism, direction, and reflection or no reflection. That would be like in fiber optic. So a lot of ways to make on and off work. At my job at the Air Force, when I was a radio troop, we were able to send emails over HF radio using an on-off method. Here's some terminology with this. What a byte represents. A byte is the number of bits to represent one character. Kilobytes is 1,000 bytes. Megabyte, 1,000 kilobytes. So you can see this is orders of magnitude increasing. A zettabyte I've never seen. A terabyte is the most I've seen, like operationally. But petabyte, exabyte, zettabyte. I didn't even know zettabyte was a term until I taught this class. So very unlikely you'll see that anytime soon, but here's some terminology for you. All computer data is represented by bits. Data can be anything. It can be photos, recordings, currency amounts, whatever. Um, Data can be all sorts of things, but they're built by bits. Disk capacities are specified by the amount of bytes. You'll see this if you're shopping for a computer, 500 gigabytes. CPU speeds are expressed in cycles called hertz. A hertz is like a cycle. Slow personal computer speed of 3 gigahertz. A fast PC would be 3.5 or more gigahertz. When I was growing up, like 1 gigahertz would be gold. That'd be enough for me to play Age of Empires versus some other pukes over 56K. But now that's nothing. That computer's obsolete. 3.5 gigahertz or more. So, disruptive new tech hardware. How can new hardware affect competitive strategies? Potentially disruptive hardware developments for existing organizations. Internet of Things, digital reality devices, self-driving cars, 3D printing. These are things that are so disruptive that it could completely change an industry. It could change the industry structure such that you're going to put businesses out of business within years because of the new technology. Think about what the internet's effect on newspapers. Newspapers aren't dead yet, but they're not thriving like they used to. They used to make huge amounts of revenue on like the want ads and classifieds. Well, they can't charge a premium for that anymore because everyone's using Craigslist or Facebook. So what is the Internet of Things? Internet of Things is the idea in which objects are becoming connected to the internet so that they can interact with other devices, applications, and services. And just look at yourself right now. You're on a smartphone or you're on a computer. You might have a smartwatch on, be it Fitbit or Apple Watch. You could have a Ring home security system, either in your dorm or apartment or at your home. At your parents' home, they could have a Ring that's connected to the internet. You could have a smart furnace. You can do so many things from anywhere because you're connected to the Internet of Things, which is cool. It's scary. Cool. Self-driving cars. This is crazy to think about how disruptive that could be. I know in the insurance world, they're worried. That's a good thing because there's going to be less crashes, theoretically. I think there will be less crashes, but that means you're charging less insurance premium, and those insurance premiums are used to invest in the stock market to make returns for the company. So without that larger base of investment, insurance companies aren't going to do so well. So that's going to affect that industry. It's sure you can guarantee it's going to affect Lyft and Uber. Lyft and Uber drivers are going to be replaced by automated cars. If you own a car and you go to work and it's parked there and it's sitting there for 8 hours, well, if you have a self-driving car and you partner with Lyft or Uber, you could say, okay, I'm at work now, I don't need my car. Go have my car go generate income for me by driving around and picking people up. So just endless possibilities with that. 3D printing. It's pretty cool. My friend got into 3D printing and devoted like hours of time every day to building this thing. Kind of ruined his marriage because he focused on that too much. But it's cool. The thing is pretty cool. When he showed me it working, I was pretty impressed. You can 3D print replacement parts to repair like a washer or dryer. He helped me print a replacement knob for some furniture. It was pretty cool. So how can new hardware affect competitive strategy? Well, everyday objects embedded with hardware capable of sensing data. Um, you have these little embeds everywhere, and you're getting immediate feedback on things because they share data with a network with any other application. So you get an email, um, and you can know about it on all sorts of different platforms immediately. Does it feel like you're ever off work nowadays? Well, not really. I know I feel like I'm always connected to work, which is not a great thing. So General Electric, their industrial internet that they built for their own company, increased efficiency, reduced waste, improved decision making because you have more information. Greatest potential for smart devices. You got hospitals, power grids, railroads, manufacturing plants. That immediate feedback is going to be huge. Think of a railroad. If there's a traffic jam in a urban area where your railroad's going to go through, and you can detect a traffic jam, well, you're going to know to slow down ahead of time before potentially smashing and killing somebody. Manufacturing plants. If there's a problem at the plant, you'll know ahead of time, so you can do a work stoppage and fix it instead of letting work pile up. Smart buildings, avoid wasteful lighting, competing heating and cooling system, rogue fans, etc. You can detect that and turn those off. Digital reality devices. You ever see that Joaquin Phoenix movie where he falls in love with the girl, the robot girl, her? We talked about in chapter 3 the love robots. This is different than that, um, but that is the potential future. It'll create entirely new types of companies, change the way people do things. There's a virtual reality place in Bloomington now where you can go play like Call of Duty virtually. And they have augmented reality like Pokemon Go, where you're in the real world, but it shows a little anime character on your phone. That would be augmented reality. I got ahead of myself. Here's augmented reality, mixed reality, virtual reality. Different levels of digital reality. Google Glass never really took off, surprisingly. Microsoft HoloLens, Oculus Rift, Facebook bought Oculus Rift, and you can see it's a spectrum of going from reality to virtual reality. Self-driving cars make things easier, cheaper, safer. Car insurance eliminated, yeah. So I was talking about that a couple slides ago. I didn't realize they specifically called that out, but yeah, that's a problem for companies like State Farm. Eliminate the need to have multiple cars, because you're parked at work, then your car can go back home and pick up your husband or wife. Avoid cost of traffic tickets. No DUIs. I don't know, you're probably still going to get a DUI if you're wasted with your automated car. And they can park themselves. That's always cool. They're going to disrupt business. Auto sales, fewer cars on the road. Auto loans. That's going to impact that. More jobs for engineers, system designers, more computer hardware. So it's going to be a mix. Look at TV prices. My wife and I were looking at 4K TV prices, and they have plummeted. They're able to do so much cheaper now, and these are going to have augmented reality in it soon, or more commonly. The self-balancing motorcycle is crazy. The Asimo robot from like 15 years ago, they use some of that tech to make this bike, which is pretty cool. 3D printing, yeah. So what happens when 3D printing, like a car, airplane, boat, house, what happens when that becomes possible? That's going to be insane. 3D printing, culinary artist produce intricate, beautiful, fully customized desserts from a robot. You don't need a fancy chef in your restaurant anymore. Alright, so what do business professionals need to know about software? Well, we got an operating system, which is a program that controls the computer's resources, and application programs. These are programs that use the operating system and the hardware to produce an outcome. You have client, you have server side as well. Client means that everything's kind of run on that machine, and server means things are done remotely. You have thin or thick clients. A thin client relies on a server to do everything. A thick client means everything is on that computer. A good way to explain this is if you've noticed Office 365, that's moving, it's kind of a mix, but it's moving more towards having things done on the server and having it be a thin application. You can do Excel on a browser, and that would be like a thin client server side way of doing it. So with an operating system, um, operating systems are going to come in particular versions that are written for particular types of hardware. If you look at, I'm not a Mac guy, but I know they have Mac OS like Mojave and Snow Leopard. They have weird names for it. But those are specific to different hardware setups. Um, with the mobile OS, it's going to be different than the computer OS. So it's going to be specific to the type of hardware. So they come in particular versions that are written for particular types of hardware. Native applications are programs that are written to use a particular operating system. So some of them only work with Microsoft, or some only work with Mac. Thin client applications run within a browser without the need to be pre-installed on computers. And thick client applications mostly run on a single operating system. Here are some operating system examples: Windows, Mac OS, Unix, and Linux. Windows used for PCs, Macs is used for Macintosh clients. Kind of started, the reputation was always for being for artists. This is no longer, Sierra I don't think is the current version anymore. Windows is the most widely used operating system. It has a touch interface. Unix is used for workstation clients, engineering, computers, CAD, architecture, difficult for non-technical users, not really used as business clients. And Linux is used everywhere. It's really catching on because it's free and there's a vibrant community that make it better. Mobile clients, you have Symbian, which is used outside of the US, or outside of North America, and BlackBerry OS, not really used so much. iOS, Android, Windows 10 as a mobile client, like for the Surface servers. You have Windows, Unix, Linux. So those are major operating systems, but they're designed for hardware. So mobile clients wouldn't be used on a PC, and vice versa. So this slide, I think this is just an advertisement for Bing, but it's supposed to show off a modern style interface, touchscreen, context-sensitive pop-up components. Here is an example of virtualization. This is a Linux Mint virtual machine, which is running inside Microsoft Windows 7. So on your computer, you have Microsoft Windows 7 in this scenario, but someone is running a virtual instance of Linux. So you can run virtual machines to do things like, I don't know if anyone has like Nintendo emulators. That kind of does this. It makes a virtual instance of running the Nintendo operating system. If you're troubleshooting like a virus, if you wanted to build a virus, you'd want to do it on a virtual environment that can destroy a virtual machine, but that doesn't mean anything because you just reset the virtual instance of it, and it doesn't actually damage your actual computer. Virtual machines is when the host operating system runs one or more operating system as applications. That's a virtual machine. And if you wanted to If we want to go one step further, virtualization is the process by which one physical computer hosts many different virtual computers within it. So why would you want to do this? Well, like I said, if you're testing a virus or something like that, you would want to um, do it in a virtual environment. But another thing at Heartland Community College, our work is all remote right now because of COVID, and so the way that we access our work computer is I don't have a work computer at home. I get on the internet and I go to a virtual instantiation of my uh, my my work desktop. So I'm actually on a virtual machine when I'm working from home. And as a business owner, that's a lot of business owners are doing this. So it's going to be important for you to know the concept of it. Another example of a virtual machine, you see you have one desktop and then you have a virtual machine in a browser with another desktop. This is going to be an important concept if you own a business. What licensing does, vendor's liability, a site license, open source, no license fee. What do these concepts mean? Well, when you own a program, you own a license. You don't actually own a program, you own a license to use the program. You don't have a license to modify it. You don't actually own that program. When you buy a Microsoft Windows license, you're buying the right to use Windows. You don't own the Windows program. Large organizations negotiate site licenses, so you don't have to pay the retail price each time. You get a bulk discount, but that means all your users can use it. And you can get into big trouble if you own a business and you have more users than you have a license for. And there are whistleblower funds that'll pay for someone for calling their business out because piracy is such a big problem. With Linux, no company can sell you a license to use it. It's open source, and so a lot of small businesses will just go to Linux because it's open source without a fee. There are some different software sources and types. You have off-the-shelf, then customized, and then custom developed. And we split it to horizontal, vertical, and one of a kind. Kind is software that's developed for a specific need. And let's see some definitions here. Horizontal market application. That is software that provides capabilities common across all organizations and industries. So think about Microsoft Word. That can be used in any industry. A vertical market application is software that serves the needs of a specific industry. It's like a dental office program used to schedule appointments and bill patients. That might be specific to a dental office or like a medical office. Custom developed software can be tailored to organization requirements, but it should be used as a last resort because it is so expensive. Now, what is firmware? Firmware is a type of computer software that is installed into devices such as printers, print servers, and various types of comm devices. It's designed into circuitry. It's like if the program's logic is designed into the device's circuitry. It can be changed and upgraded like other software, but normally that's a task for IS professionals. So here's some examples of open source software. Ubuntu I installed on my computer. That's pretty cool. So I'll talk about some big data concepts later. But yeah. So I always wonder, why do programmers volunteer their services to open source projects? Well, it's a challenge and it's fun. They exhibit skills to get a job. They like being creative. It's pretty cool. But if you're doing programming, you'll find tons of answers in online communities, and it's wonderful. Here's what some source code looks like. Looks like JavaScript. Open source. meaning all the code is available for any user to see. And so open source is something that State Farm dipped its toes into, and it's great because it is free and wonderful, and you don't have to buy licenses. There are some problems with some things that it's you're told specifically not to use it for commercial enterprises, but some they're fine with. And so you want to be very careful about those stipulations. But free open source software might require support and operational costs exceeding the cost of a licensing fee. So just because it's free initially, it could cost more in the long run. With a closed source project, you have highly protected code, only available to trusted employees and carefully vetted contractors. So there's pros and cons with either strategy. So how does this help you? Well, it helps understand your involvement with tech. Learned a little bit about hardware and software, gained some knowledge of application software sources, and considering a little bit about open source software and why it might not always be a viable option. So thank you, and that is chapter 4.